Okay, geometry, chapter 4, section 3, triangle congruency by ASA and AAS. It's angle, side, angle, and angle, angle, side. Okay, so postulate 4.3 states the angle, side, angle postulate. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. So in this example, if angle A is congruent to D and C is congruent to F, and the included segment between those two are congruent, then the triangles are congruent. Alright, it's angle, side, angle, just the way it reads. So it has to be an angle, the next thing better be a side, and then the next angle. Okay, so let's look. Which two triangles are congruent by angle, side, angle? So I have an angle, angle, angle. Off of that angle, I have a side. I have a side. I do not have a side in this one. And then, finally, I have a concluded angle and an included angle. So, angle, side, angle. So those are my two triangles that are congruent. Okay? So how would I list it? So I would say triangle. I'll go UVS is congruent to triangle. U and E are the same. V and O are the same. And S and M are the same. So triangle UVS is congruent to triangle EON. So next example. Which two triangles are congruent by angle, side, angle? So I have an angle, and I have an angle, I have an angle. I have a side. I do not have an included side. I have an included side. Then I have an opposite angle and an opposite angle. So I have triangle GHO. G corresponds with C. H corresponds with A. O must correspond with T. So triangle GHO is congruent to triangle CAT. Okay, easy enough. Angle, side, angle. Writing a proof using angle, side, angle. All right, members of a teen organization are building a miniature golf course at your town's youth center. The design plans call for the first hole to have two congruent triangle bumpers. Prove that these bumpers are congruent. Okay, given segment AB, let's get a darker color, AB is congruent with DE, okay. Angle A is congruent with angle D. We have that side congruent with that side. B and E are both right angles. Let's do it in black, I guess. So I have, for this triangle, I have an angle, a side, and an angle. I have an angle, a side, and an angle. So I can prove angle A is congruent, I can prove AB is congruent, and angle B's are congruent. So I have triangle congruency by angle, side, angle. Okay? Can we prove these two triangles are congruent? Given CAB, angle CAB is congruent to angle DAE. We are also given segment BA is congruent to EA, and angle B's and E are right angles. So I have angle, side, angle, congruent angle, side, angle. So I have it concluded. So easily enough, I can say triangle ABC is congruent. Triangle ABC is congruent with triangle AED, just by looking at the sides. Okay? Now, that was pretty quick, pretty easy. So we're going to go on. Alright, so lesson check real quick. You know, our triangle RST, which side is included between the two angles R and S? Well, it would have to be side RS. You could draw it if you're not sure. RST, that angle and that angle. Okay. So obviously it'd have to be that side. Okay, number 2. In triangle NOM, NO is included between what angles? Well, angle N and angle O. Should be pretty straightforward. So angle N, angle O. Which postulate or theorem could you prove triangle ABC is congruent to DEF? Well, I have a side congruent to a side, or an angle congruent to an angle. I have a side congruent to a side, and I have an angle included to an angle. So I have ASA, ASA. So I have congruency by angle, side, angle. Okay. Moving on to part 2 now. Triangle congruency again by angle, side, angle, and angle, angle, side. Now we're going to really focus on the angle, angle, side aspect. Theorem states this, okay? Theorem 4.2, our angle, angle, side theorem says if two angles and a non-included side of one triangle are congruent to two angles in the corresponding non-included side of another triangle, then they are congruent. So if I know A is congruent to D, I know angle B is congruent to E, and I know AC is congruent to DF, then I know triangles ABC is congruent with triangle DEF. So going on. Now you have seen and used 3 methods of proofs in this book, a 2-column, a paragraph, and a flow. Each method is equally as valid as the others. Unless told otherwise, you can choose any 3 methods to write a proof. Just be sure your proof always presents logical reasoning and justification. Okay, writing a proof for angle, angle, side. So here's what we know. We're given M is congruent to K. So the measure of angle M is congruent to K. We know that WM is parallel to RK. So prove the triangles are congruent. Okay. Well, angle M is congruent to angle K. That's given. WM is parallel to RK. That's given. Angle MWR is congruent with KRW because they're alternate interior angles of parallel lines. All right. We know WR is congruent to itself. So by angle, angle, side, we can prove the 2 triangles are congruent. All right. Given angle S is congruent to angle Q, RP bisects angle SRQ. So if it bisects it, we know this angle is congruent to that angle. So we have given angle S is congruent to angle Q. We're also given segment PR bisects angle SRQ. So we know angle SRP is congruent to angle QRP because that's the definition of a bisected angle. We also know segment PR is congruent to itself by reflexive property. So I have two congruent angles and a corresponding side. So I can say triangle WMR is definitely congruent to triangle RKW. Oh, sorry. Triangle SRP is congruent to triangle QRP. Okay? Let's just go through a couple of quick problems, and then we're done with this one. Determine whether two angles are congruent. Okay, multiple choice. Use the diagram at the right to justify if triangle BIF is congruent to triangle UTO. Well, I got B is congruent to U. That's good. I got I is congruent to T. I have OT congruent to BF. But I do not have, because it's got to be in the exact same order, I have angle, angle. I don't have this side proven. I have angle, angle, side. I have this angle, and this side. So I do not have the sides corresponding. So no. The answer is B. No, F and B and OT are not corresponding sides. The diagram shows that two pairs of angles, one pair of sides are congruent. The third pair of angles are congruent by third angle theorem. But we can't prove it. We can't prove congruency because of angle, angle, side. They both fail because F, B, and TO are not included between the same pair of congruent angles, so they are not corresponding. The correct answer is B. All right. Are angles PAR and SIR congruent? Okay, so let's look. I know this angle and this angle are congruent, don't I? I also know this angle and this angle are congruent. So I know angles, so let's write this out. Angle A is congruent to angle I. That's given. What else do I know? Segment PR is congruent to segment SR. That's given. So I can say angle ARP is congruent to angle IRS. Why? Vertical angles are congruent. So I have enough information for angle, angle, side. So I can say with confidence triangle ARP is congruent to triangle IRS, which I could rewrite as triangle PAR is congruent to triangle SIR by angle, angle, side. Okay? Good stuff. That is it for proving triangle congruency with angle, angle, side, and angle, side, angle. So review this and then the other ones from 4-2 with side, 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 and sine, angle, side, and you'll be rolling.